Stan Gibilisco here to promote my book Optics Demystified, which you will find at Amazon.com. I recommend you get the paperback edition. I've noticed several reviews now saying that the Kindle editions of my technical books leave a lot to be desired, but the paperback versions have been seen by me physically, and that is the book I always recommend that you get. With at least with my technical books, I would recommend it. Taking it from there, the topic at hand is optical fiber and the way that light beams propagate through them. There are two types of optical fiber shown here. At A is what we call a stepped index optical fiber. That means the index of refraction, which is higher in the center and lower in the outside, has an abrupt boundary between the two layers. The core, which is the more dense or the higher index of refraction, and the cladding, which is the lower index of refraction. At B, I show you a graded index optical fiber. It looks kind of like the same as if there's a boundary here, but there really isn't. What it is the greatest index of refraction in the center, gradually getting less and less and less until you get to the outer jacket. Now, in the case of a stepped index optical fiber, a beam of light will reflect at this boundary right here between the higher index of refraction in the core and the lower index in the cladding, provided that this angle of incidence doesn't get such that it passes through and strikes the jacket of the cable, in which case you lose everything. So you can't make too sharp of a bend in this type of a cable, nor can you do it in this type of an optical fiber, because the same thing will happen. But instead of reflection here, you get refraction because of the gradual transition between higher and lower index of refraction. Remember that a beam of light is always gravitated in a way towards the higher index of refraction in an optical fiber. It will refract in a graded index fiber and reflect at the boundary in a stepped index fiber, provided that you don't make too sharp of a bend in either type of cable. So that's just the very basic fundamentals of how light goes down an optical fiber, and lets you make it a little bit less than straight, but certainly you don't want to bend any sharp corners. That's a no-no in a lot of aspects of life, but particularly in optical fibers. We'll go to Saturn, where I'm making this video from, one of the moons of Saturn, taking a little sabbatical here and visiting my home away from home on one of these moons. I won't tell you which one. I've told you why before. And I will include a link to this page in the description of this video so that you can browse through the book and see whether you want to buy it or not. Amazon is pretty good about that. It's kind of like going into a bricks and mortar bookstore, and you can look at the contents. You can look at the way I write, a little bit of it. You can't download the whole book, though. In order to do that, you've got to pirate the book. And I sure wish you wouldn't do that. Otherwise, I may have to retire permanently to the moon of Saturn on which my vacation home exists. Real estate's pretty cheap up there. Taxes are non-existent. And I can just gradually become more and more, oh, what do you say, absent-minded. Stan Gibilisco signing off from Optical Fiber Land. Until next time, so long.